Hi, thank you so much for joining me today. So I'm Hilal. I'm the Chief Information Security Officer at Razorpay. And today I want to talk about how we do threat detection at scale at Razorpay. So to begin with, a little bit about Razorpay. Razorpay is one of the leading fintechs in India. So we do close to maybe like this is old data, but we do more than $150 billion of GMV every day. We do more than 100 million transactions per day. And because we are a fintech, we have some unique security challenges that we have to address, both from the regulatory point of view as well as from the business point of view and the trust point of view. So we need to be able to basically scale the security because of the complex demands of the fintech industry, which demands that we have compliance and governance as the top of priorities. So at Razorpay, we have an intricate and very complex basically tech stack, which comprises of microservice from Kubernetes. We have basically layers of resilience and scalability built within the services. And to think about basically every single transaction that we actually do, each API call actually is like 150 requests and responses, which means that if you do like 100,000 requests, which multiply that, but that becomes 15 million requests and responses like every minute. So which means that there's a massive dependence on our tech stack to be resilient and to be scalable. And to address basically scalability and resilience with security, it takes a special amount of effort to basically make sure that our security is actually completely comprehensive and deals with basically the demand of the basically transactions. So what it does is basically like we have massive amount of automation built in, and that allows us to basically scale our security service and security stack to be able to basically maintain any security incident isolation as well as basically reduce human errors that actually can be possible due to basically the nature of our services. So we use, like every service, every fintech, like we use a bunch of AWS services. And today, like I would not actually go through all the services that we actually use, but in order for us to basically identify, protect, detect, or respond and recover from security incidents, we use a bunch of AWS services, including AWS GuardAD for detection and basically detecting any kind of anomalous or suspicious activity. And we use AWS Inspector for basically managing the vulnerability and application security posture. And we do use, actually, apart from that, we use basically a bunch of other Lambdas and AKS and all the services to be able to basically respond and recover faster. So and all of this actually consumed basically like a bunch of we do not use them in isolation. So all of these services actually come together and form a solution. And that solution is actually what we actually use in AWS, in our infrastructure, to be able to basically do threat detection at scale. So this is now, yeah. So in order for us to basically address the unique challenge that we have in security, particularly basically for financial transactions, right? So one of the challenges is that like our customers are not necessarily end user or consumers. We have like business, we are a B2B kind of like setup where we actually support both the major banks in the world and as well as we also support basically end users or say mom and pop stores. So think about it, like say for example, a simple incident like a DDoS or a distributed denial of service attack. So if that's actually discovered in our infrastructure, what happens is that we cannot just use basically a traditional defense mechanism like volumetric basically defenses or establishing any kind of thresholds or throttling the requests from the merchants, right? So because some of the merchants may actually do like a ton transactions per minute, but some of the merchants may do actually like more than 1 million transactions per minute. So we cannot just use throttling as a defense against DDoS attacks or something like that. So in order for us to be able to basically defend against attacks like DDoS and something else, we needed to be more agile. We need to be a little bit more innovative to be able to basically defend against those kind of attacks. So what we do is basically we use not just basically the traditional defenses, but we complement that with our in-house built, basically AWS machine learning algorithms and things like that, so that we actually are able to basically dynamically basically address any kind of DDoS attacks that are being projected against our infrastructure. So this is a very unique situation, and similarly, we have other incidents as well. We demand that we have customized and unique defensive mechanisms against those kind of incidents and attacks. So now, basically, so that was basically the introduction. Now I want to go a little bit deeper into a couple of some use cases that we have actually done at Razorpay to address some of the special needs. So in order for us to basically build these solutions, right? So we needed there are three things that were actually very, very important. So one was the security solution that we actually developed needed to be simple, it needed to be scalable, and it needed to be it needed to basically provide the coverage that's necessary for us to be able to detect and respond faster. So one of the things that we did was we created a secure custom landing zone. So if you have ever actually deployed any kind of service control policy, or you have developed any control centers or any kind of landing zones, and you have multiple accounts, both legacy and new ones, and you keep on adding accounts. So one of the challenges that you have is basically to synchronize and basically come at a bare common minimum platform where you can actually build those policies which can be implemented in secure landing zones. So, and this was a massive challenge for us because we had legacy accounts, we had customer accounts, we have partner accounts, and those were not always going to be at the same level of basically hygiene. So what we needed to do at that time was basically we worked with the AWS solution architects, our internal security team worked on it. Despite their best efforts, we were not able to basically use the AWS provided control centers and control towers and SCPs. So what we did instead was basically we created our own custom landing zones. So instead of basically saying that, okay, we are going to create default basically control towers, what we did was that we said okay, let's do one thing. Let's actually create all the child accounts that will host any kind of resources will actually get basically depending on the SIPs that we actually design. So whenever we actually had an account or a resource or any kind of basically service that we actually spin in the AWS account, a CloudTrail event will actually get generated. And that CloudTrail event is going to be basically sent through the event bridge, and that event bridge will actually use the step functions to basically incorporate all the SCPs that we actually built. So which means that no matter where we actually introduce any new account or any existing account or any kind of new child accounts, they will get the custom SCP policies that we actually designed. So what this did for us was that we did not necessarily have to have that conflict between different accounts. We did not have to basically go back to the native landing zones or custom control towers that AWS actually built in. So rather than depending on, because at the end of the day, the control tower is basically nothing, it's a bunch of policies, right? So that allow us to build hygiene within our infrastructure. So that's what we did. We actually adopted that idea, and instead of using the default landing zones, we created a custom landing zone that allowed us to basically implement security by design or privacy by design, depending on the use cases that we had. And so this was one of the building blocks for all of our security strategy, and it really worked well. So second, basically the use case that we actually solved through cloud native security was, all of us have heard about basically cloud native application protection platform, Synapse or something like that, right? So everybody has an idea what they actually do, right? So for us to be able to prioritize vulnerabilities, because no matter what you do, so every time you open an inspector or you open your vulnerability management program, what happens is that you see a massive amounts of basically security vulnerabilities that need to be fixed. And they have variety of basically severities, a lot of different things that you need to actually address for those vulnerabilities. So because we also suffered the same thing, we had thousands of vulnerabilities one fine day that needed to be solved. So instead of actually going back and saying that, okay, what are we going to do about it? So what we did was we created our own Synapse platform, which was basically built on native AWS services, which is amusing because everybody thought that, okay, Synapse can only be third-party integrations, or you need to have a comprehensive basically platform to basically do Synapse. But for us, what we did was basically every time basically we had those vulnerabilities, we actually passed them through, we use step functions massive, on a very large scale. And all the step functions and function-based step sets that were always integrated through the services to prioritize the vulnerabilities. So what they did was basically like we had a very nice way of actually like classifying the vulnerabilities into basically actionables and basically address them depending on their priorities. So this was always done through basically we used the instance IDs at a large scale because we thought that that was actually the unique parameter that would allow us to basically isolate the vulnerabilities to be able to basically address those gaps that were within the infrastructure. So this was something that we did with the help of basically Security Hub and step functions. And we also basically like managed to kind of like include basically the external intelligence and basically the threat detection mechanisms to be able to basically like judge or determine basically the severity of the vulnerability in a much more objective fashion. So this was a very cool thing to do because what it did was basically earlier when we had like thousands of basically vulnerabilities that needed fixed, due to basically additional enrichment of the vulnerability threat detection mechanisms, we were able to basically get them under control and really like bring that thousands of vulnerabilities back to like, it was not like tens or something like that, it still was hundreds, but we still managed to bring them to a manageable level. So one of the challenges that basically like we always faced was basically adopting something like a responsive mechanism to basically security incidents. And a SOAR platform is always a tricky thing. Basically, either it works or it does not. So there's nothing. And depending on basically the number of playbooks that you design or number of basically like workflows that you actually like design, it's always going to be challenging to basically respond to events with confidence. So unless like you're very, very certain that a particular incident can be treated in a certain way or needs a remediation in a particular way, you're never able to go into basically automate remediation because you're always concerned that you may actually bring something down, or so there may be service breakdown, there may be problems in our infrastructure that we may not be able to provide the availability that's necessary. So what we did was basically like for all the basically SOAR use cases, what we did, once we were positive that a particular incident has happened, and we have positive, okay, this impact is going to be like this, what we did was we created our step functions that allowed us to basically like scale that security response to be able to reduce that mean time to respond and mean time to detect. So every time we got an alert from GuardDuty, or it was a CloudTrail event, or it was a third-party security event, so what we did, we fed that into basically our event bridge, and event bridge will actually go to invoke the step functions, and then we'll actually like automatically remediate the vulnerabilities or the security incidents that would actually be discovered at that time. So now one of the cool things about this was that we used external threat intelligence like MIST platform, and we use some others, both commercial and open source threat feeds to be actually like to make sure that we have much more objective way of basically classifying the vulnerabilities or security incidents so that our confidence score actually goes way high. And once we are actually sure, say for example, like we are confident that through a MIST feed, we are confident that a particular IP has a bad reputation or a URL has a bad reputation. So what we do is basically we are much more comfortable in actually like invoking a playbook or a workflow that will automatically remediate that particular vulnerability. So this allowed us to basically use a cloud native basically kind of response mechanism without actually having to have a third party or an external security operations orchestration and remediation platform. So now this one was very unique. So everybody actually has struggled with basically like EKS clusters, and you have different types of basically nodes that you have control nodes, you have worker nodes and things like that. And you are never sure about, okay, like what kind of security you want to basically implement, right? So the visibility and the monitoring of EKS clusters is always going to be challenging. So in order for us to basically like say that, okay, like because, and the other problem, the other challenge with EKS clusters or EKS nodes is that there are always going to be dynamic resources. So that resource may actually exist today, that may not exist tomorrow. So you still want to make sure that you have some visibility across your all EKS platform setup. So one of the things that basically like we did was that we said, okay, let's enable GuardDuty across the EKS clusters. Like make sure that all the microservices that we actually use has both the visibility on the EBS and EKS setup, right? So what it did was every time the GuardDuty alerted us, or there was that basically like there was some kind of like incident or kind of like alert that actually was generated by GuardDuty, and said that there is a malicious or infected pod. So now what do we do with that? So actually the problem is that like you just cannot actually isolate that in basically when you're actually in the function. So one of the challenges was to basically make sure that we identify it positively and then isolate it from the rest of the infrastructure so that the infection does not actually spread. So, and this needed to be basically like executed in real time, so or near real time. So one of the things that happened was like once we got an alert that a particular pod was infected, so we would actually like extract basically pod information, and we'll actually make sure that okay, that particular pod which was infected was labeled through basically Lambda functions. We used Lambda functions to label those infected pods, and that was dynamic because we used basically like say like instance ID or something like EKS node ID. I actually basically put a one more tag, additional tag, that said that okay, this particular node is basically infected node. So once we actually did that, so what it did was it allowed us to basically isolate those particular nodes. And that was something that really was needed in terms of making sure that, okay, the infection does not get to the other nodes basically like quickly. So all in all, so what happened in this particular instance was that whatever we detected some malicious activity, which was through suspicious network activity, or if there was a malware infection, or there was some kind of CNC activity or any kind of basically malicious activity that was detected by GuardDuty. So we labeled them with basically a tag, a custom tag that said that it was this particular pod was actually infected. And once it did that, it was a bit easy for us to basically like do the isolation because we cut it off from the rest of the network and ensured that, okay, it went actually into basically passive resource and did not become active after we actually implemented that policy. So what this allowed us was basically, it allowed us to basically respond a lot more quicker to basically any kind of EKS vulnerable or weaknesses. This was super cool, and I think this was one of the things that we did where we did not need any third-party security for microservices. So we have like a massive, like as I said in the beginning also, that being a fintech, so trust and security becomes our cornerstones for our business. If we do not actually maintain the trust and we do not maintain the security of our platform, it's very difficult to business because we move a lot of money. So because we move money, everybody is very sensitive about how do we do that. Is our platform very secure or not? So we have massive amounts of complexity in terms of the integrations that we do with the banks. We do like integration with the different customer platforms. We do integration with our partners. And that integration is not always going to have the same or basically benchmarks for security. So we need to basically ensure that all the integration that we do, it actually has common minimum security that actually like ensures that our security platform is not actually compromised. So what this entire exercise did when we said, okay, we are going to basically like leverage the native tools to basically build solutions. So what it did was basically it actually challenged us to think differently. So for example, the malicious pod isolation, like there were solutions available in the market, but they offered us more than what we needed, and which was not really ideal because then we had to basically figure out what do we do with the rest. Like it's not like so. We needed a slimmed down version of basically like some microservices security. So this allowed us to basically innovate and basically become more creative, and we created solutions that were based completely on the native tools that were available to us. Very rudimentary, but very effective. So apart from that, I think this entire thing that we actually discussed, the 4 use cases that we discussed, that was first was basically creating a custom landing zone to enable us basically governance across our accounts. Second was basically creating a native CNAPP application protection platform. The third one was basically like managing basically the remediation at scale and remediation at a very fast pace. And the fourth one was basically like around basically our microservice and the security of our Kubernetes infrastructure. So all of this actually basically made us actually aware that, okay, there are a lot of things that we can do. All we have to do is basically like align the service in the right way, basically create a solution that actually brings the services together that we actually use. And it just needs a little bit of basically using the right services with the right amount of basically like configuration that we need. Some of the things that we did, for example, the posturing of our applications, posturing of our infrastructure was basically done through native tools. So in the end, actually, this security is always going to be a journey. We can never, ever say that we are finished with security. And the cloud is actually a tool that enables us to basically adopt this service at a much faster pace. We are able to innovate much, much faster, but that's pretty much good, but because our adversaries do that as well. So we need to always be ahead of this, basically the code to be able to respond to new and novel threats, emerging threats, and things like that. So thank you so much. Appreciate your time. And do let me know if you want to talk a little bit more about it. I will be around. And again, thank you so much for joining me for this learning.